This is a study on the Texas Instruments 12, 14, 16-bit Octal-Channel DACs. Welcome to the training module on the 12-bit resolution DAC 7568. This training module covers how to interface the DAC to an MCU and the application information. The 16-bit DAC 8568 and 14-bit DAC 8168 and 12-bit DAC 7568 digital-to-analog converters from Texas Instruments targets data acquisition systems, industrial process control, and portable instrumentation. Their internal references provide temperature drift performance of 2 parts per million per degree C typical up to 5 parts per million per degree C maximum across the entire operating range for twice the accuracy of competitive devices. According to TI, the internal reference, which saves space and cost compared to external references, also offers a high initial accuracy of plus or minus 0.004% typical and plus or minus 0.002% to help eliminate the need for full-scale system calibration. This device, targeting applications such as industrial process control and portable instrumentation, the DAC 8568 16-bit, the DAC 8168 14-bit, and the DAC 7568 12-bit digital-to-analog converters from TI integrate 8 channels in a TSSOP-14 package or TSSOP-16 package. Features include a power of 0.56 milliwatts per channel, including internal reference current, and a temperature drift of 2 parts per million per degree C up to 5 parts per million per degree C max. The internal reference offers an initial accuracy of plus or minus 0.004% typical and plus or minus 0.002%, and the output glitch energy is 0.1 nanovolts per second. The DAC architecture consists of 8 string DACs, each followed by an output buffer amplifier. The resistor string is simply a string of resistors, each of a value R. The code loaded into the DAC register determines at which node on the string the voltage is tapped off to be fed into the output amplifier by closing one of the switches connecting the string to the amplifier. It is monotonic because it is a string of resistors. The output buffer amplifier is capable of generating rail-to-rail voltages on its output, giving a maximum output range of 0 volts to AVDD. To enable the internal reference, write the 32-bit serial command when performing a power cycle to reset the device. The internal reference is switched off default mode. In the default mode, the internal reference is powered down until a valid write sequence is applied to power up the internal reference. If the internal reference is powered up, it automatically powers down when all DACs are powered down in any of the power down modes. This page gives you serial interface features that exist in this device. It has 3-wire serial interface, sync, S-clock, DIN, which are compatible with SPI and OSPI and microwire standards. It has 32-bit shift register, which consists of 4 prefix bits, 4 control bits, 16 data bits, and 4 feature bits. The data format is straight binary, with all zeros corresponding to 0-volt output and all ones corresponding to full-scale output. This page gives information about the different power down modes present in the DAC. There are 4 power modes which exist here. These modes are selected using the PD1 and PD2 bits. Power up selected DAC, power down selected DAC, 1 k ohm to ground, 100 k ohm to ground, power down selected DAC, high Z to ground are the different modes. Load regulation is defined as the change in reference output voltage as a result of changes in load current. The load regulation of the internal reference is measured using force and sense contacts. The force and sense lines reduce the impact of contact and trace resistance, resulting in accurate measurement of the load regulation contributed solely by the internal reference. The MSP430F449 microcontroller will interface with the DAC 8564 using the SPI Serial Data Communication Protocol via the MSP430's USART T0 port. Only 2 pins are used from the 4-pin SPI motive configuration. It is implemented this way because there is no need for reading any data back from the DAC 8564 or having the MSP430 microcontroller be enslaved by another host peripheral for SPI purposes. Therefore, the STE and the MISO functions in SPI mode of the USART T0 port are not used. The DAC 8564 receives a 24-bit digital input word serially because the SPI only provides 8 data clocks per transmission. 3 write cycles are required within the sync low period to complete 1 write cycle to the DAC 8564. Here we show some of the interfaces between the DAC and the microcontroller. In 8051-based MCUs, we use UART interface connections like TXD, RXD, and SYNC. SYNC is derived from a programmable port pin. In microwire connection, the data are shifted out on every falling edge of a serial clock. This page gives some application information about this device like internal reference, supply voltage, noise performance, and thermal hysteresis.